6 PhD students and more than 20 postgraduate students. He has published more than 50 technical papers, and he has conducted many training programs and delivered expert lectures in many colleges and forums. He has completed many consultancy projects of government and private sector. Sir is working as an expert in various committees of AICT, GTU, and other universities of Gujarat, Directorate of Technical Education, and Education Department of Gujarat State. Sir has also authored books on mechanics of solid, which is published by Tata McGraw Hill. And so, without any more delays, I would request now Bijay Shah sir to start with this session.
Yeah, thank you, Vinith, for this brief introduction. And almost good afternoon to all the participants. Today we are going to discuss about the fundamentals of the genetic algorithm, the techniques, evolutionary techniques, which is widely used in the problem of search and optimization. As you know that after the arrival of our computers, we can easily solve any complex problem. As such, problems are always complex, right? We many times for the solution, during the solution, we simplified it, and we try to get the solution. But when we simplifies, there is always some sort of a compromise. Compromisation is always there when we simplify the problem. Of course, we always take care that the overall behavior should not be changed, but there is always some amount of compromisations when we simplify the problems. So that is why people prefer to solve the as it is real problem. But as we know that the real problems are always complex problem, and up till now, before the arrival of our computers, we were handicapped because it involves a higher engineering mathematics, which is sometimes very difficult to solve it, derivative integrations, and manually it is almost difficult to solve it. So that is why we were unable to solve it. But after arrival of our computers, all the numerical methods and computational methods are very easily able to use it, and we can solve any of course a complex problem we can solve it. Again, we can say that when we say it is a complex problem, we need to always do some sort of a simplification to understand the behavior, because complex problems are very difficult to understand. So that is why to understand the overall behavior, simplification is always required, and that is why to what extent we can go for simplification, that is decided and that can be done depends on the type of the problem, right? So with this initial background, we are going to today start with the fundamental of genetic algorithm, because these evolutionary techniques are widely used in the direction of search and optimization, and particularly in engineering domain, engineering problems, this is one of the quite essential part. So we are going to discuss this thing. Very simple method is there, but very powerful tool is there which can solve I think a very complex problem, right? So I will share my desktop, and will share the presentation, and then we will go ahead, right? So I will share my desktop. I'll go to a presentation, and please let me know this presentation, my desktop is visible to everyone or not. Please share your views. Okay, just it is going on. Presentation is just now loading. Okay. So I think the first screen is visible to everyone. Is it okay? Okay. Right. So this is the today's topic, fundamentals of genetic algorithm, and the first quote I am going to put it, who is almost we can say it is a father of genetic algorithm, John Holland. John Holland is known as a father of genetic algorithm, And after putting a lot many efforts in this area, he found and he put his quote, and very interesting quote is there, that living organisms are consummate problem solver. They exhibit a versatility that puts the best computer program to shame. I think all of you can very easily see this statement and understand that we are always a consummate problem solvers, right? Any difficulty, any problem arises, we are trying to find out, we are trying to solve it. So every during even our life also, we are always facing lot many problems, and we always I think we can say that the entire life we put it in solution of the problems, right? This is the life basically. Many problems are facing, and we are getting the solution of it, and at one day we are going out from this world. So every living organisms are consummate problem solvers, and they exhibit a versatility that puts the best computer program to shame. I think the God has given us the brain, which is many times we have heard that we are utilizing a very small part of it, but those who are utilizing it, I think for them they exhibits a versatility. Our brain, God has given this brain very versatile instrument that puts the best computer program to shame. Any best computer program which are available on this in this world, I think it can never compare, nowhere compare with the God which is given us, right? So I think this is a very interesting quote given by the father of the genetic algorithm, John Holland. Let's see some of the facts as far as this genetic algorithm is concerned. Genetic algorithm is basically a part of evolutionary computing, and which is a rapid growing area of artificial intelligence. As we know that today there is a what we can say, everywhere we are talking about, everywhere in slowly and gradually this AI, artificial intelligence, is going to be a dominating, right? Many gadgets, the AIs are being used. So everywhere this AI, now it's a era of the artificial intelligence. So it's a part of evolutionary computing, which is a rapid growing area of AI. A genetic algorithm mimics the principle of natural genetics and natural selections to constitute the search and optimization process, right? So it is basically based on the principle of natural genetics and natural selections in the direction of search and optimization. GA are robust search technique which inspires by the Darwin's theory of the evolutions, that is a survival of the fittest principle. I think everybody's are quite aware about this survival of the fittest principle, and we have also realized it very well, this principle, that if you are going to fit, then you will be able to survive. If you are unfit, as in when you are going to be unfit, you will be out of this thing, right? So survival of the fittest principle is, I think, very well applied in our human life also. And this technique is basically the base of the genetic algorithm. So that is why it is a robust search technique. A robust search technique. Why it is a robust search techniques? Because in the base, in its foundation base, it is based on the Darwin's theory of evolution, survival of the fittest principle. GA developed by, these are some of the contributors, John Holland, as we have seen in the very first slide of the famous quote, Richenberg, De Jong, Holstein, Goldberg, they are the great contributors as far as the field of genetic algorithm is concerned, right? Let us we see the contributors contributions in the areas of the genetic algorithm. The Reichenberg 1960 introduced the idea of evolutionary computing in his work Evolution Strategy. So this is the initial point of GA. Reichenberg has introduced some of the ideas of the evolution strategy. which carry forward by John Holland in 1975 in the first conceived the concept of genetic algorithm in his book Adoption in Natural and Artificial Systems, acknowledged as the beginning of the research in the genetic algorithm. So that is why we call the John Holland is the father of genetic algorithm, because he conceived the concept of the genetic algorithm in his the book, first book, right? So this is the first book available. Then after De Jong, he has captured the feature of the adaptive mechanism in the family of genetic algorithm that constitutes a robust search procedure. So adaptive mechanism that feature is captured by De Jong in this genetic algorithm, which gives the robustness. Then Holstein has made analysis of the different selection and the matching strategies on the performance of genetic algorithm. We will see somewhat in details about these two different parameters, selection and the matching parameters, right, which are basically the base of the genetic algorithm. So how it is going to affect on the performance of GA, that will describe by Holstein. And Goldberg in 1989 describes the nature of genetic algorithm by combining a Darwin's survival of the fittest procedures that is capable of addressing a broad spectrum of the problem. So with the survival of the fittest principle, incorporation of the survival of the fittest principles, it's what we can say, the spectrum, it covers now the broad spectrums of the problem, and one can do very well. So I think Goldberg is the professor of University of Illinois, and right now also you will be, once you will search David Goldberg, there is a very good book of David Goldberg on genetic algorithm. Those who want to start with genetic algorithm, they can get this book of David Goldberg. I think it is the very nice book available to understand the fundamental basics of the genetic algorithm, and then after how it can be carried forward to the complex problem. So Goldberg from University of Illinois right now also is working there, and he has really giving a boost to this genetic algorithm to address the broad spectrums of the problem. Right? As we know that there is a motivation from the nature. Nature is, I think, the great source of motivators, and in the foundation of this method algorithm, this is it is inspired from the nature. So that is why it is a robust search and optimization techniques. So as we know that most biologists believe that the main driving force behind the natural evolution is the Darwin's survival of the fittest principle. That is, as we know, right? In most situations, the nature ruthlessly follow the two simple principle. So let us see which these two principles are there. The first one is, if by genetic processing an average above average offspring is created, it is going to survive longer than an average individual. I think that we have seen, and thus have a more opportunity to produce the children having some of its traits than an average individual, right? So this is the entire what we can say, the genetic process. And in the genetic process, if above average offspring is created, there is a more chances of surviving longer than an average individual, and it has a more opportunity to produce the children having some of its traits than average individual, right? So this is one of the very important features. And second, if on other hand a below average offspring is created, it does not survive longer and thus gets eliminated from the populations, right? So this is I think very well under survival of the fittest principle is there. And we have also observed this thing very well in our day-to-day life. We can see that basically in our human system, the two people the male and female people are going to meet together through a routine process called a marriage, and then after they met each other, and we have seen that if the parents are good, it is more more chances that their childs are also found to be even what we can say the more comparatively higher than their parents, right? So this is observed, and day by day, that is why our new generation, as we told, that the new generation is found to be a more what can say the compared to a clever as compared to older generations. So that is a reason for that. That above average offspring, if it is created, it is survive for a longer time and more opportunity to produce the children having some of its trait than the above average. We many times says that our what we have seen in our younger age, the younger generation, the new generations, they are getting at a very lower age, right? So this thing we found it, they learn also very fast. So all these things are ultimately the result of this Darwin survival of the fittest principle. And if the below average offspring is created, it does not survive longer and gets eliminated from the populations. So basically, this principle is already embedded into the mathematical form in this algorithm, and that is why this algorithm is found to be a very robust algorithm, right? So this is basically motivation from the nature. So let us see some of the things. Of course, application part here I have listed a few of these, but I think there is a wide spectrum of its application. You will find not only to engineering, but almost many areas of optimization, automatic programming, machine and robot learning, economic model, immune system model. Even in medical field also you will find a lot many application, ecological model, population genetic model, interaction between evolution and learning, models of social systems. So I think everywhere you will find out, because search and optimizations, I think very large domain, a wide spectrum is there where you can apply this genetic algorithm. Image processing, genetic algorithm is also used in image processing. Wherever you will find out any applications in the search and optimization domain, you can apply the genetic algorithm, right? So here I have listed couple of it, very few of it I have listed here, but I think you will find a lot many than which I have listed here. I will talk related to the civil engineering, and I'll talk somewhat about the structural design and optimization, how this genetic algorithm is used. So that will give you some idea as far as the civil engineering is concerned. So all of you have gone with the process of designing, structural design, whether it's structural design or mechanical design or any design is there. All the engineering people have faced with this designing. Designs are always there, engineering design is there. So what is engineering design, and let us see what is optimization. I think if you compare these both things, you will just differentiate the things. The goal of the engineer, like any engineer, is to design structures or mechanical component or anything, sir, any engineering components which are safe, functionally efficient, and the economical. These are the three attributes one has to careful while designing the structures or any component which are going to be safe. It is to be functionally efficient and the economical. The structural engineer should make the best use of the available resources to balance between the safety and economy, right? Safety and economy, these are both the aspect one has to be take care while doing engineering design. Of course, safety gives a first priority, but economy also should be given a second priority, right? Economy cannot be with the compromisation of the safety, right? So that is why safety and economy, both the issues we need to understand, because we are living in the developing countries. The importance of each and every pennies are known to us, right? So that is why economy, safety is definitely one of the concern, but economy is also a second concern one has to look forward, right? Whereas optimization That is the act of obtaining best under the given circumstances. This is the important thing, right? Act of obtaining best under the given circumstances. Circumstances here need to be defined. And under these circumstances, restraint circumstances are nothing but one kind of a restraints for us. So under these restraints, what the best we can get it, that is called the optimizations, right? Many times, so that is why when we are talking about optimizations, what are the restraints? What are the circumstances? These are always to be a matter of concern. And under these circumstances, what best we can obtain, that is called the optimizations. So in design, maintenance, production, constructions of any engineering system, engineer has to take many technical decision at the several time. So that has to be taken care during the optimizations, right? So that is why each problem, when we are talking about the optimizations, once the constraints are changed, once the objectives are changed, the problem will be changed, right? What is your objective? What is your constraints? So these are what are the design variables. So these always to be matters in the problem of optimizations, right? So this I think you might have studied during the initial 2 days of this course. Some of the preliminary as far as the optimization is concerned. So this will help you to understand this thing in a much better way. So let us this traditional design, any real world problem is there, we can generate the data to describe the structures. We can start the initial design, or many times we call it as a preliminary design, based on our experience or based on the rule of thumb which is given. We can assume certain parameters, and based on this assumed certain parameters, we can analyze this problem, and after analyzing we can design it, and let us see whether it satisfy all the criteria, codal criteria, and all the criteria are there, serviceability criteria, stress criteria, all these criteria, if it is going to say satisfy, then it is okay. And if it is not going to satisfy, then we have to modify the design based on the modifications required, and then we can finish the design, right? So design is also a trial and error process based on the criteria which is defined by the code, like limit state of collapse, limit state of serviceability, durability, and many more criteria which is defined by the code. If it is satisfying, then it is okay, and if it is not satisfying, then we have to go for the redesign. So this is a traditional design. Whereas in the optimizations, any real problem is there. In any optimization problem, you need to identify three things. First is the design variable. Which are your design variable? What is your objective? Whether it is there is a single objective, or it may be a multiple objective. So what are your objective? And last one thing is a constraints. So these three things are needs to be defined into any problem of optimization in the beginning, right? First thing is design variable, objective functions, and the constraints that needs to be satisfied. And based on that, we can generate the data to describe the structures. We can initial design, analyze, and here the important thing is, does the design satisfy the convergence criteria? In any optimization problem, the convergence criteria are there, because if your what can say the solution is fall into a feasible region, all the criteria will be set, but all the criteria will be satisfied. But whether your result is going to be converse or not, and it is really the optimum solution or not, so for that we check the convergence criteria, right? Is it okay? Am I audible? Okay. Okay. So if the criteria, convergence criteria is satisfying, then it's okay. We can get the optimal solutions. And otherwise, if the convergence criteria is not satisfying, then we can modify the design parameters, and then again we can go the things, right? So this is some of the what we can say the flowchart for traditional design and the optimal design. Little difference is there. Here three important parameter: design variable, objective functions and constraints that need to be set before the starting of the problem. Various methods of optimization you might have studied in the first 2 days. Traditional methods are there: classical, linear programming, non-linear programming, dynamic, and many other methods are there. And evolutionary, non-traditional, genetic algorithms, simulated annealing, cellular automata, and many other non-traditional methods are there. Where genetic algorithm we are going to discuss in detail. So it is a one shot of a evolutionary programming techniques, and that we are going to discuss. Right? How GA differs from the traditional optimization process. You might have seen some of the traditional optimization process: linear programming, non-linear programming, and right, many other integer programming, dynamic programming. How GA differs from this traditional optimization process. So let us see. GA works with the coding of the parameter set, not the parameter themselves. In all the optimization problem, we can directly deal with the parameters, whereas here we are going for the coding of the parameters, right? So we cannot use directly the parameter, but we are using a specific method of coding, and these codings are going to work. So this is the first difference in the genetic algorithm and traditional optimization process. Second, GA search from the population of point, not a single point. This is one of the very important features of the GA, and that will ultimately help us to get the true optimum solutions. You might have seen many optimization problem. We can start from a one point, and then after we can decide the direction in which we have to move. Step length or gradient or many other parameters are to be there in the traditional optimization process, right? But in all the process, we can start from a one point. Randomly, we can start with any one point, and then after we can move in a specific direction. So that is there in the traditional method. Whereas in the GA, instead of a single point, we can start with a multiple point into a design spectrum, or the spectrum of search and optimization. And because of that multiple points, I think we can get the true optimum solution. Whereas there is always a possibility of get trapped into a local optima into a traditional optimization process, right? So this is one of the what we can say fear into a traditional optimization process, that whether we are getting a true optimum solution or not. So we are not sure about it, whereas here we are starting with the multiple points. So that is why we are very sure to get the true optimum solution. Then GA use a payoff functions. Basically, it is a one kind of objective functions, and which does not involve any derivative calculus or other auxiliary knowledge. Right? Most of the time in all the optimization process, it involves either derivative calculus, and many times the people do not like it, this derivative calculus, and that is why they are afraid of it and they do not use it. Right? Whereas here such kind of derivative calculus are not at all involved anywhere into the process, and that is why everyone can easily understand this method. Right? GA use a probabilistic transition rule, not the deterministic rule. So that will gives the robustness, because it involves probability involved in the process. And genetic algorithm use random based on the earlier informations to guide the search instead of gradient search, so that the derivative information, step size calculations are not necessary. In many traditional optimization process, you might have seen some of the methods are gradient based, and where the step size involved and derivative involved, calculation involved. All these things are just you are moving ahead all the things, right? So randomly the search and directions will be decided. So this is one of the important features of it, right? Let us see, because it has a biological background. Genetic algorithm has a biological background. So some of the terminology of the biologies, which you can use it here, and what is exactly terminology we are using into our biology, same thing can be reflected here into the mathematical form, right? So let us have the relation between natural and artificial terminology. So in natural terminology, we are using the terminology chromosome. Here we are using the term genetic algorithm. We are using the term string. So we are making a string here, and that string is ultimately reflecting the same thing, chromosome, into a natural terminology. Gene, so that relates in genetic algorithm features, characters. So whatever features, character which are reflecting, that will be in human body also gene. Many times you can say the gene whenever it is differs, the features, characters differs. Allele, it's features or value, features value, right? So that is known in biology allele. Here it is known as a value, features value. Locus, that is a string positions. So locus of this body or cell. So this will be reflected here. It is a string position. Genotype, so that is the entire structures or population is known as a genotype. And phenotype, that is a parameter set, alternative solution, decoded value. So these are the words which we are using into a genetic algorithm. So I think as we have seen that it has a biological background. So you can very well compare with the terminology which we are using in the biology, and the same thing will be you can relate with the genetic algorithm. So this terminology we are going to use it into our coming sessions. So please be, I think there is nothing any difference with the. We will be not using any biological words, but we will be using the terminology which we are using into a genetic algorithm. Okay, so let us see what is this algorithm is. Okay, so this genetic algorithm, it's very simple, and these 4 steps involved into this genetic algorithm, and these are very simple 4 steps are there. Okay, first thing is creation of a population of the string. So we have to create the population. So this population is, let us call this is the first generation. So in this generation, you can create as many population as required. It depends on the size of the problem. So first thing, we create a population. Then evaluation of each string in populations. Number of peoples are there. So here number of peoples are called a string. So we are going to evaluate each and every string. So that is called the evaluation processes. How we can do this, all these words that we will discuss in the coming sessions. So evaluation. Then based on the evaluations, again we will move to our next generation. So from first generation to second generations when we will be moving, then there are certain method, selection method, in which we make such a way that some good strings, right, the good people will be moving to the next generations. So why? Because if the good people will be moving to a next generation, there is a possibility, as per the Darwin survival of the fittest, that if good people are moving in the next generation is found to be a more fit compared to the earlier generations, right? Or the present generation. So that is basically a base, biological base. And so that the third step, selection, very important stage is there in this algorithm, and many different methods of selections are there which we can use it, so that the next generation will be stronger, or I think we can say the good generations, right? uh, and the last is the genetic manipulations. After making a selection also, we can have a certain what we can say the manipulations are going to make, so that these new populations which we are going to form, it will be with modification. Otherwise there is no meaning. If older generations are there, if they are transferred to the new generation, it does not make any sense. These new generations also, they are going to mate with so number of strings are going to exchange the information. As we know that in a current what we can say the scenario, the male and female, they are going to mate with each other, and they exchange their features, exchange their informations, right? So that part is required to be carried out here into the process. So only selection will not serve the purpose, but genetic operators are going to apply so that they can exchange the informations, and the new generation which is going to form. And these new generations, because as the biological backgrounds are there, that good peoples are going to transfer into the next generation, and they exchange their informations. there is a possibility to get the above average or the what we can say, the next generation becomes a more powerful than the earlier generations. So this is basically the 4 steps involved into this algorithm, and these 4 steps are basically used into the mathematical formations will be there. Many algorithms are there. Many of what we can say the operations are there which we are going to do to what the words which are writing here. Create a population, how to create a population, how to evaluate a populations, how the selection will be carried out, and how the genetic operators are to be applied. So these are the 4 simple steps are there in this algorithm, but it will do a marvelous things and giving a robust search in the optimization process. Same thing is put it here into the form of a flow chart. Generate initial population, evaluate the populations, assign the fitness, select the new populations, and various genetic operators are to be applied. And again, this is a quite repetitive process because it is a generation, as we have seen the human evolutions starting from the starting of when the human came into this world from Adam and Eve. Now you can see the populations. So it goes for n number of generations, and after having a n number of generations, this what we can say the brilliant people are found in this on this earth, right? And again, the new generation will comes that will be more intelligent than us. So this generation here, generations or day by one generations. So these are nothing but the number of repetitions. So after having a number of generations, we will be able to find out the solutions, right? So what exactly the human beings evolved, the entire process of evolution of the human beings are captured into this algorithm, and that is why this algorithm is basically the strong algorithm. Okay, so let us see outline of the basic genetic algorithm. Okay, so first thing is the start where the generate random population of n chromosomes. Then we can evaluate. So here the word fitness is being used. Fitness of individual strings, evaluate the fitness of each chromosome into the population. So that is called the evaluation process. Then new population. As we can see, these new populations where many processes are involved. Create a new populations by repeating following steps until the new population is complete. First is the selection. So select the 2 parents chromosome as we do in a human being. The male and females they are going to mate. So select the 2 parent chromosome from a populations according to their fitness. Right, the better the fitness, the bigger chance to be selected. So here these are the criteria which we are going to use. Better the fitness, bigger chance to be selected. Then crossover, with a crossover probability, certain probability, crossover the parents to form a new offspring, that is called a children. If no crossover was performed, offspring is an exact copy of the parent. So that is why here the crossover is required. If we are not going to make the crossover, then we can get the exact copies of the parents. So that will not serve the purpose. So that is why the crossover is required. Mutation, with a mutation probability, again here the probability is used. So with a certain probabilities, mutate the new offspring, whichever the new offspring is formed. So mutate the new offspring at each location, position in the chromosome. Again here there is an exchange of information, but here with a very small probability we change only 1 or 2 bits, right? We do not change the entire thing. Entire majority of the what we can say the information will be done in the crossover stage. Here we give little bit, right, just to give a little divergence. So that is a mutation. And accepting means after doing all this process, whatever the new offspring is formed, so that will be a part of the new population, right? So these new populations covers these 4 basic process: selection, crossover, mutation, and accepting, right? So how we will do that again we are going to discuss in the coming session, and then we can replace the new generated populations for the further run to the algorithm. and then test whatever our criteria are there, that criteria are going to test, and if the end condition is satisfied, then we can stop. Otherwise, return the base solution, retain the base solution into the current populations, and we can move ahead, right? And then repeat from step number 2. So based on the fitness, again we can go for the new population where we can select crossover mutation accepting. So likewise, one by one generation, we can create a new set of the populations. They can select, they can exchange the information, and then coming out to a new set of populations which we are going to test. So fitness test is carried out, and based on the fitness test, whether it satisfies the criteria, whether the convergence is achieved or not, based on that we can decide whether we have to repeat or we have to stop, right? So this is again a repetition involved here based on the convergence which are going to achieved or not, right? So I think very simple algorithm is there, but it involves a lot many things. So let us see the graphical description of this genetic algorithm basics. So this is the first power, we can see the population. Here we are creating a set of population. So each one you can see these are the individuals. Okay, so each one individuals are there. So here each string is called the individual, and all the strings combined together is nothing but a population. And this is, I think, the one generation, right? So this is basically the things which we are going to use it. Basically here it is a binary coding, so that is why it will be reflected in terms of 1 and 0. Many coding methods are there which we are going to discuss in the coming session. So this is a simple thing. Binary is very easy to understand, 1 or 0, and based on that we can make the things, right? So we can see that the top blocks, these are binary numbers which represents the population. Each row is an individual that represent one solution to the design problem, right? Each row is an individual that represents one solution to the design problem, that is called a string. One individual is made up of all the design variables concatenated. So here in an individual, it involves the design variable. So this problem consists of a 3 design variable. So these 3 design variable makes a one individual, and likewise number of individuals are there, so which will called a populations, right? So you can see here in this figure there are 3 design variables. So see the first design variables. So first design variables are, let us see, so the first design variable, one can see that here is the first design variable, right? It involves the 6 bits 100 101, right? So this is the things. Okay, then this is the second individual. You can see that this is the second individual, and this one is the third individual, right? So in this way the 3 design variables are there, and these 3 design variables are going to use it so into the one individual. So 3 design variables are there. First design variable of 6 bit, the second design variable, these are of the 7 bit, and third design variable, these are of the 4 binary digits. Initial population is generated randomly. So this is also need to understand. Initial population is generated randomly, and then after it is created by various selection method and the genetic operators. So these things are to be carried out. So this first initial population which we have created, that is randomly, this process is made randomly, and then after applying a various selection methods and the genetic operators, the next generations will be carried out. So this is simple graphical description of the genetic algorithm basics. Let us see more in detail. Traditional optimization problem, as we know that all the optimization problem which involves either maximization or minimization of the objective function. So let us say the maximize or minimize the objective function fx subject to the constraints are there, and these constraints is gjx greater than or equal to 0. So it may be a equality constraints, inequality constraints. So whatever type of constraints are there, we have here the number of constraints. So this can be there, and the each design variables has a upper and the lower bounds. So as we have seen in the earlier problem, three design variables are there. So in all the engineering design, always there is a bounds, upper bounds and lower bounds. So in between upper bounds and lower bounds, optimization is the act of obtaining best under the given circumstances. So given boundary is given to us. So within this boundary, whatever best we can get it, that is called the process of optimization. So that is why here upper bound and lower bounds are there for the design variables, and within these bounds and subject to the constraints which we are going to satisfy, whatever best either maximization or minimizations, that is nothing but the optimization problem, right? So it is a optimization problem. Let us see how do we we can do a coding. So first part is a encoding, right? Binary coded strings. Binary coding is a very simple thing to understand. So that is why in this fundamental of genetic algorithm, we will be discussing more about the binary coding. But if you refer to our literatures, many other coding methods are also available. Okay. So binary coding is very easy. It will be in the form of a 1 and 0. So it is to be used. The length of the string is usually determined according to the desired solution. What is the accuracy, solution accuracy we required? Based on that, the length of the string will be decided. As you have seen in the earlier slide, the design variable 1, 2 and 3, design variable 1 is having a 6-bit, design variable 2 is having a 7-bit, 3 is having a 4-bit. So how this length can be decided? That is based on the desired solution accuracy. What is your accuracy? Based on that we can go for deciding the length of the string. Okay. For example, if the 4 bits are used to code each variable in the 2 variable function, suppose our optimization problem involves the 2 variable x1 and x2. Okay. So it's 2 variable. It can be put it in this way that the first variable and second variable. So let us have that this reflect the first variable x1, this variable the second variable x2, and this will form a complete string, right? So when we are talking about its upper bound and lower bounds, there is a there is a things that all the strings are having a 0, that will always gives a lower bound, and all the strings all the things are 1, so that will gives us a upper bound. Okay. So upper bound and lower bounds, all the values are 0, then it is a lower bound. All the values are 1, then it is upper bound. So this will represents x1 lower, x2 lower, and x1 upper and x2 upper. Okay. So this represents the upper and lower bounds. This can be decided because in optimization, that is the problem differs from this upper bound and lower bound. You have to define your domain, right? Your spectrum needs to be defined. So in any engineering problem, what is a minimum value, what is a maximum value that we are going to specify? So that is nothing but your upper bound and lower bound. Suppose one design variable is there, depth of the beam and width of the beam is there. So normally we define the width of the beam, that is maybe a 6-inch or 9-inch or 12-inch or what is the maximum, whatever. So this way the upper and lower bound decided. Similarly, depth of beam also we can decide upper and lower bound. So this all design variable needs to be specified the upper and lower bound, and then based on certain mapping rules are available to decide the value of that variable. So once the upper and lower bounds are decided, you can decide the accuracy. So for any variable xi lower bound plus difference of upper bound and lower bound. So this is the difference of upper bound and lower bound 2 raised to L, that is the length of the string, because it is a binary, so that is why it is a 2 raised to L, length of the string minus 1, and multiply the decoded value. So by using such kind of a mapping rule, one can decide the value of variable, right? So this value of variable can be decided in that way. So such kind of a mapping rule are normally used to convert from encoding to a decoding, right? So encoding to decoding, such kind of a mapping rule are used. Then fitness function, next parameter. Fitness functions GA are basically naturally suitable for solving the maximization problem. So this is naturally it is suitable, GA is suitable for the maximization problem. So as such, you can solve the maximization problem, but when you have to go for a minimization problem, you need to do a certain transformation process. So usually transform into a maximization problem by some suitable transformation. So this may be given in any what you can say the topics of the optimization. In a classical method, this might be given that how can the maximization problem be transformed into a minimization problem. So such kind of a transformation process shall be applied to convert from maximization to the minimization problem. So for maximization, fitness function will be taken as it is the objective function. Whatever objective function is there, same can be used as a fitness function. But if it is a minimization, you may use such kind of a transformation process, and this can be done. So fitness function fx can be taken as fx, here small fx is a objective function. So this is basically a objective function. So objective functions will be put it into such way in the denomination form. So 1 upon a way, such kind of a transformation method can be used to determine to use for the minimization problem. Okay, so this way the fitness function will be used. Very important operator. Basically, genetic algorithm gets the power, right? That is from the genetic operator. So these genetic operators are the very important part of the entire algorithm, and many genetic operators are available into the literature. If you go to the literature, many genetic operators have been identified. That is reproduction, how to reproduce the next generation or next population, how to cross over to exchange the information, mutation, inversion, deletion, translocation, segregation, migration, sharing. So many genetic operators are that is available into the literatures. But mainly, basically 3 algo operators are the main operators as far as this genetic algorithm is concerned. That is a reproduction or selection. We have used the word selection many times, we have used in the past, but there is also another terminology called the reproduction, right? When we move from one generation to another generations, the reproduction will take place, right? So either reproduction or selection, how it can be carried out, crossover, how the exchange of information will be carried out, in the mutation. So these 3 parameters, the 3 operators are widely used into the genetic algorithms, and then after based on there are, as I told you, that many operators are available into the literatures. This can be used, but basically in all the things, these are the 3 how to go for reproduction and selection, and how to exchange the information. These are basically the base in the genetic algorithm, right? So this is there. Let us see what is reproduction and selection. So reproduction is usually the first operator applied into the population. This is the first operator. Reproduction selects the good string in a population and forms a mating pool. Right? Some good strings they are going to select from the population and form a mating pool. Hence, it is sometimes also known as a selection operator. There exist a number of reproduction operators in the GL literature, but the essential idea in all of them is the above average strings are picked up from the current population and their multiple copies are inserted into the mating pool in a probabilistic manner, right? This is basically the idea of all the selection or the reproduction operator, that the essential idea is that above average strings are picked up from the current population and their multiple copies are inserted into the mating pool in a probabilistic manner. This is basically the main thing behind this reproduction operator. Okay, crossover. Basically, in the crossover operator, new strings are created by exchanging information among strings of the mating pool. So whatever good strings are to be put it into a mating pool, they can now exchange the informations. So new strings are formed by exchanging the informations with some probability here, because it is a probabilistic part is involved. So that is why here crossover probability is used. So with certain probabilities, they exchange the informations. Many crossover operators exist in the GL literatures. Again, the same thing is there. In most crossover operator, two strings are picked up from the mating pool at random and some portion of the strings are exchanged between the strings, right? So this is the important thing, that is many crossover operators are available, many methods are also available, but basically the two strings are picked up from the mating pool at random. Again, randomness is there. Okay, we should not have any bias in the entire process, and that is why probability, randomness, these are to be involved, right? So that we can get an unbiased solution. So two strings are picked up from the mating pool at random, and some portion of the string are exchanged between the strings, right? Original strings. So this is there. Let us see. This is a single point crossover. This is say a single point. See here there is a one string. So this is a one string, okay, and this is another string, and this is basically a crossover point. Okay, so that is why it is called a single point crossover. Based on certain probability, whatever probability you can decide the crossover point. So you can see that this green part, which will be transferred here in the first string, and this white part which is transferred here in the second string. So likewise they can exchange the informations. So after crossover, you can see that the exchange of information will take place from first string to second string. So this is called as a single point crossover. Similarly, 2 point crossovers are also there, multi-point crossovers are also there, and uniform crossovers are also there. Many other strategies are there. In the GL literature, you will find many other strategies to go for exchanging the information. This is just a simple one to understand, that is known as a single point crossover. So here in a single point crossover, they can exchange the information with first string will get the copy of second will get the part of the copy, not full but part of the copy into a first one. So likewise, they can exchange the information, and that is known as a single point crossover. With the crossover probability, whatever crossover probability we can decide into our problem, we can exchange the information. So this is a example of a single point crossover, but multi-point crossover, 2 point crossover, and many other things are available into a literature. Mutation, the third important thing. This mutation, it changes 1 to 0 and vice versa with a small mutation probability, right? Only small, with a small probability, 1 or 2 bits or a small part of the bits are going to change. So this is called a mutation. The effect of the mutation is to reintroduce divergence into a converging problem. That is the very important part, and that is why we can get the global, what we can say, the true optimum solution. It will not interrupt into a local optima, but it will we will be able to get the global optima. The effect of this mutation is to reintroduce divergence, right? Little divergence will be given, right? But with a small probability. Otherwise, if we give a more divergence, it is very difficult to get the convergence. So we give a very small amount of divergence, low probability, right? So that is why here a small probability is being used. to reintroduce a divergence into a converging problem. How important its role is, still it is a matter of the debate, right? You might have also worried that already we have done same thing into a crossover, why we are doing into a mutation. Okay, so there is a lot of debate among the researchers, but most people believe that the mutation plays a secondary role into a simple genetic algorithm, right? Simply it involves a little divergence so that somewhere the problem is stuck up into a local optima, we can move towards, we cannot get into a local optima, right? So that is basically the purpose, and that is why with a small probability it will exchange 1 to the bits will be changed from 1 to 0 or 0 to 1, vice versa, with a small mutation probability, right? So you can see here that this is a old one, right? So this is a old string here, and see only one bit that is going to change here, while rest of all the bits remain as it is. Okay, rest of all the bits remain as it is, only one bit is changed from 0 to 1. You can see with a blue color, so this bit is only going to change from 0 to 1 or 1 to 0, vice versa. This will be there. This is called the process of a mutation, right? And with a very low probability, this task is being carried out. Otherwise, if you do a high probability, it is as good as the crossover, right? So whatever steps we have done past, that is no need to repeat it. So that is why to give a little divergence, we only with a small probability we change the bit from 1 to 0 or 0 to 1. This process is known as a mutation. Let us see these parameters of the GA. What parameter we should take? So first the thing is a crossover probability. Crossover probability says how often will be the crossover performed. That is called a crossover probability, right? If there is no crossover, offspring is exact copy of the parent, right? I think we can easily understand. If there is no crossover, offspring is exact copy of the parent. If there is a crossover, offspring is made from part of parent's chromosome. Part of parent's chromosome. If crossover probability is 100%, then all offspring is made by crossover, right? So if it is 0%, the whole new generation is made up of the exact copy of the chromosome from old population. So I think there is no need to make 100% or 0, but you need to fix up in between 100 to 0%. So crossover is made in a hope that new chromosome will have good part of the old chromosome, and maybe the new chromosome will be the better. So that is basically the expectation which is to be there in this crossover, right? Mutation probability, again it says how often will be the part of the chromosome mutated. If there is no mutation, offspring is taken after the crossover without any change. If the mutation is performed, part of the chromosome is changed. If the mutation is 100%, whole chromosome is changed. If it is 0%, nothing is changed, right? So I think mutation is made to prevent falling GA, genetic algorithm, into a local extreme, right? But it should not occur very often. Too high mutation introduce too much diversity and takes longer time to get the optimum solution. Too low mutation tends to miss some near optimal points, right? So that is why we have to make a balance between these two tasks. We should not go for too high mutation, we should not go for too low mutations. Otherwise, we are not able to get the real optimum solutions. So with these expectations, one has to go select the mutation probability. Other parameters, in other parameters, population, what is the population size? How many chromosomes are there in the population in one generation? How many strings are there? That is called a population size. If there are if there are too few chromosomes, we take only few chromosomes, GA has a few possibilities to perform the crossover, because in a crossover two strings are going to mat. So matting pool, in a matting pool also there should be a sufficient number of chromosome or the strings. So that is why there is no meaning to have a too few chromosome, and a small part of the such space is going to explore. On other hand, if there are too many chromosomes, if we are going to use a too many chromosome, GA will slow down. Okay, so researchers shows that after some limit, it is not useful to increase the population size because it does not make solving the problem faster. Of course, the computer will do, but every computer has a limitation. So that is why looking to this thing. So if the population is too small, genetic algorithm will converge too quickly, and hence there is a possibility of getting a local optimum point and may not find the global optimum solutions. On the other hand, too many members in a population result in a long waiting time for significant improvement, right? So convergence, to achieve the convergence, I think large number of generations are required, and that will slow down the GA process. So some of the recommendations are there. So these recommendations are very general. Recommendations are often results of some of the empirical studies of the genetic algorithm which were performed on the binary coding. Remember that it is on the binary coding. Crossover rates, normally it should be high, 80 to 95 percentage crossover probability. Mutation, very low, base rate is 0.5 to 1 percentage mutation probability. Population size, it may be surprising that very big population size usually does not improve the performance of GA in the meaning of speed of finding the solution. And good population size is 20 to 30. However, sometimes it depends on the type of problem. You may even go for 50 to 100. So these are some of the trials and errors required into the problem to decide the population size, crossover parameter probability, mutation probability, right? Selection, there are many selection methods are available, but stochastic based methods are more used in the process of selections. There is also some more sophisticated methods which will change the parameters of the selection during the run of the genetic algorithm. Selection is as good as you are knowing right now the IPL is going on, right? Of course, there are only 8 teams are there. You might have seen that how the process is being made. Initially, the league match are there. Each team is playing with other teams 2 times, and likewise 14 matches are there. So it is one kind of a tournament method. Tournament selection is there. So there is also one of the method known as a tournament selection. The way in which you can apply here that two teams are going to play with each other, two teams are going to play with each other, and one, whatever the best team will be there, that will be going into the next generation, right, into the next level. So the tournament selection is there, roulette wheel selection is there, stochastic based methods, selection methods are, so many selection methods are available into the literatures, right? But the elitism surely improves this. Elitism means whichever best is there, always you can keep this best into all generation, right? In each generation, whichever the best is found, that will be kept. So likewise, it will improve. So this process, this is known as the word elitism, will improve the performance of the genetic algorithm. So what the best options are there, it is not going to be dropped into the next generations. That will give more number of copies into the next generations. So which will improve the performance of GA. Encoding, again, there are many encoding methods are available, depends on the type of the problem, instance of the problem. Binary encoding is used here, which is very easy to understand. Initially, GA started with the binary encoding, but then after hexadecimal codings are there. Real coding, right now real coding genetic algorithms are also used. So these are the evolutions which are going to make into the genetic algorithm time to time. So you can refer to the literatures. Binary coding is very easy to understand the process of genetic algorithm. So that is why here also I have used the binary coding. And crossover and mutation depends on the type of the problem, you can use it. So let's have a simple example. Maximize these functions, two variable functions x and y. Okay, x minus 7 square y minus with interval x and y on the interval 0 to 7. X and Y, both the values are varies in between 0 to 7. So these are the upper bound and the lower bound. X varies 0 to 7, Y also varies in between 0 to 7, and we have to maximize the functions. Genetic algorithm starts with a population of string to be able to generate successive population of the strings afterward. So we can start with initial populations. The initialization is usually done randomly. First population, first generation is to be made randomly. This means with the binary strings of, for example, every allele is set to 0 and 1. In a binary, I think it is a 0 or 1. So you can just what we can say, toss the coin, and if the head will come, it is 1, tail will come, it is 0. So likewise, tossing the coin, you can make the string. Okay, so this thing can be carried out. Let us see the initial population. Just to understand, I have only go with only 4 string into this population, and these 4 string which are made, the first 3 strings which represents the first 3 bits represents the X value, and next 3 value represents the Y. So here you can see this 1 and 0 will be made by just tossing the coin. You can toss the coin. If the head will come, it is 1, tail will come, it is 0. So likewise, the first 3 bit represents the X value, second 3 bits, the next 3 bits represents the Y value. Okay, and how this value, so likewise this is the first string. Similarly, same way with the same process, you can go for getting the second string, third string, and the fourth string. As many string you want in the population, likewise randomly. If you are using a computer, the random function is available. So with the random function, you can also create such kind of a string. And how to get the value of this string? So binary coding is there. So I think all of you are very comfortable to use its value binary conversions. So the first 3 string, it is 100. So its value is going to be 4. Then Y value 001. So this Y value 001, that will be getting A1, right? So in this way, the value of X is equal to 4 and value of Y is equal to 1, that will equivalent to this binary string. I think it is very easy to understand. Very simple thing is there. So likewise, the value of second string is evaluated. It is 1 and 4. Value of third string is evaluated. Value of X is 6 and Y is equal to 2. And value of fourth string is evaluated. X is equal to 0 and Y is equal to 4. So this way the initial population is to be made. A binary representation of the 6 bit has been chosen, where the 3 bits on the left represent the value of X and 3 bits on the right represent the value of Y, and that is why the X and Y value is to be determined. Okay, so this is the things. Evaluation. After every generated population, every individual of the populations must be evaluated to distinguish between the good and the bad individuals, right? So here the fitness test is carried out. So this is done by mapping the objective functions, that is called a fitness function, right? So this is the X and Y value, putting the X and Y value into the objective function, value of X and Y, we can have objective functions. So in this way, by putting the value of X and Y, we can find out the value of string. So value of first string is 30, 37, third is 2, and fourth is 50. So likewise, the fitness will be evaluated. Then based on the fitness, we can go for the reproduction or the selection. Again, as I told you, many methods are available. This is a very simple method here I have adopted, that based on this thing, the fitness of all the 4 strings, this is a 13, 7, 37, 2 and this, right? The average can be carried out. So this is a percentage, right? So total value, total fitness is equal to 102. Here the cumulative is made. So 13, in the 13, 37 is added, so it next is 15. Then 52 is added, so 52. 52, 50 is added, so 102. So total value, total fitness is 102. So based on that, you can carry out percentage. So the first string carried 12.30, 12.7%. Second string is carry 36%. Third string is carry 2%. and fourth string is carry 49%. And based on that, how many expected counts are there? Okay, so based on this average, whatever the average we are getting, so individual divided by average. So if you carried out, you can get the expected count, right? So these expected counts can be carried out. So the first, based on the percentage, the 12.7 percentage, and the average, you can find out the expected count. So for first string, you are getting 0.51. Second, you are getting, so this average of this normalize is carried out, and individual divided by average, if we can carry out, then we can get the expected count. So this is 0.51. Same calculation is carried out here so that you can easily understand. The total fitness is 102, average fitness is 25.5, and based on that the expected count is carried out. So 13 divided by 25.5, so we can get the expected count is 0.51. For second string, expected count is 1.45. For third string 0.08 and fourth string 1.96. Now again you can use it here. If it is a 0.5, then you can go for the next higher digit. So based on that 0.51 is there, so I take it a 1 count here. 1.45, so I take it a 1 count here. 0.08, so I take it a 0 count here, and 1.96, so I take it a 2 count here. Right? So likewise, you can take the number of copies. So here, 1 copies of the first string will be going into the next generation. 1 copies of the second string will be going into the second generation. For third string, because it is a 0 count, so it will not going into the third generation. And the fourth string, so for 2 copies of the fourth string will be converted going into the next generation, right? So this is one of the method of getting how many copies of good string will be going into the next generation. Similarly, you can also go for a tournament selection. In a tournament selection, let us say the 2 strings are there, number 1 and 2. They are going to play with each other. And out of that, whosoever will be the best, so best will be going into the next generation. Then 1 and 3 will be playing, and whosoever will be the best will be going into the next generation. So likewise, you can play a tournament between the 2 strings, so that is known as a tournament selection. So many such kind of a selection process are there. So here this thing will be there. Then selected, I have gone for a first and second, there is a 1 copy, and third and fourth, 2 copies of the fourth string that will be going. So here you can see third and fourth. Here the 2 copies of the 2 copies are going for the fourth string. This is a second string, and this is the first string. Okay, that is to be there. Now here some crossover point I define here. Actually, it is carried out based on certain probability, but just for understanding here, I have considered this as the crossover point. So this crossover point, this information will be transferred here, this information will be transferred here, right? So 2 strings in the next generations are going to exchange the information. So this is a crossover with certain probability. Remember again, I have not used a probability here. I have gone with a single point, but actually this can be carried out based on probability. Number of crossover points can be decided, and the things, the information can be exchanged. And then after mutation, see here, the mutation is carried out. So this thing is carried. So after crossover, the mutation with a very low probability, only mutation is carried out at one point. The new strings are to be formed, right? So this is the new string. So these new strings are to be formed in the next generation. And the value of the fitness of the new strings are basically calculated in the same way. So based on that, you can see the sum of the fitness. Earlier it was a 102. Now you can see the sum of the fitness is improved from 102. Earlier generation, initial population, the sum of the fitness was 102. Now it is improved to 163. Average fitness was in the initial population, it was 25.5, and this is 40.8. Right? So likewise, one by one generation, the selection, crossover, mutation process will be applied. So number of generations will be carried out till the convergence is achieved. Right? So this process will be repeated till the convergence is achieved. Okay? Yeah. I think time.
கூகுள் ஃபார்ம் அனுப்புறான், வாட்ஸ்அப்லயும் போடுறான், இதுலயும் போடுறான்.
I think time.
இதுல
Minute time. Time is
என்ன சொல்றான்,
about to over.
நாங்க அட்டனன்ஸ் டவுன்லோட் பண்ணுவோம், ரெண்டு அட்டனன்ஸை கம்பேர் பண்ணுவோம் அப்படின்றான். அப்போங்க என்னடா இது?
Hello.
Yes, sir. Sir, you can unmute yourself, sir. I have muted all the participants. Sir.
Sir, unmute yourself, sir. We can't hear you, sir.
Shah, sir, please unmute yourself. Shah, sir.
Hello. Okay. Yeah. I have unmuted. Okay. So I think there won't be much time, isn't it? Because I'll take a small some just finished the matter. Just within one or two slide, I will conclude the matter. So, in the summary, this GA is an effective tool for structural optimization. There is a less possibility to get stuck into a local optima. Based on coding of the string, each string represents a distinct value of design variable in the design spectrum, and that is why this is best suitable for the discrete optimization. This is very important thing, that wherever the discrete all our engineering optimization are the discrete optimization. From the available solution, from the available design variable, we can go for the optimization. So that is why wherever there is a discrete optimization things that are required, I think this is very well useful. Computationally expensive, but it is not a problem of present day computers. Computational efficiency can be increased by parallel processing, and performance of GA depends on the high survival rate of good strings pattern or schemata. The number of string with the similarity at certain string positions is called the schemata or the things, right? This is just to improve the performance of the genetic algorithm, how to what we can say, how to keep it the good string into the next generation. That is the matter to things, right? I think we can stop here. What is Professor Vinit? Because 1:30 has already taken place. So let us, if anybody have a, because now it's an application part, but as we are here constrained with the time, again here we need to have optimization. There is a constraint of the time. So under the constraints, I have tried to what we can say cover the fundamental part of the genetic algorithm. Right, application. I think you have many sessions in this FDP, so where you will be see the applications also. Right. If anybody have any doubt, then I think we can discuss.
Yes, if anybody has any doubt in the fundamental understanding of genetic algorithm, then you can unmute yourself and ask. Application part, we are having a session on day 4.
You have a separate session, so where you can discuss.
And this 1.5 hour is very short time to discuss any of the application. So
Yeah.
if you have understood
So
the fundamentals, if you have understood the fundamentals, it will be more interested to
later on.
See the
Later on, you will be enjoying in the applications with this fundamental knowledge.
Sir, I want to ask 3 questions. Sir, first of all, I want to know the base on which we decide the fitness criteria. How we decide the fitness criteria?
See, basically fitness criteria is nothing but our objective function. Okay, our objective, whether it is going to be minimize or maximizations. Suppose we are taking a structural engineering problem and I want to have a optimization of minimization of a weight. So minimization of a weight is my objective function, right? So this minimization of a weight or likewise any objective function or any objective you can define. So that is nothing but a fitness function. Now the fitness function is you have seen our example fx is equal to, I have taken x minus this equation which is written here, x minus 7 raised to square plus y minus 3 raised to square or something. So this is one of the objective function that you need to derive in the formulation of the optimum problem, optimization problem. In any optimization problem, you need to derive this objective function. And based on whether it is a maximization or minimization, the fitness function will be there. If it is a maximization, then you can take the same as a fitness function. And if it is a minimization, then you have to transform any maximization problem into a minimization problem. So this transformation method I have shown. So accordingly, you can convert the inverse of that thing 1 over 1 plus fx. Such kind of a transformation methods are available in optimization literature. So you can use this fitness function, right?
Okay, sir. Thank you. Sir, how can we differentiate between deterministic, stochastic, and hybrid algorithms?
Deterministic, where any probabilistic, stochastic rules are not to be used, so that is called a determinant. It is a fixed one, determined, right? Stochastic, where probabilistic rules are to be there, and hybrid is a combination of both the things.
So I always get confused between hybrid, because hybrid is, when we say combination, so it is basically near to stochastic, isn't it?
No,
So
no, no,
why
no.
we are having a separate
Many times, certain variables are having a deterministic in nature. Certain variables are a stochastic in the nature, right? So, in a problem, when you are having a combination of both the types of the variables, then we can call it as a hybrid problem. Okay. Similarly, in algorithm also you can have certain rules are deterministic rules, certain rules are stochastic rules. So when you are going for combination of both the things, then it is called a hybrid one. Right?
Okay. Sir, in
Sir,
one
I
of
have
your
one
slides
question.
you have used, I have a last question, may I ask?
Yeah.
Thank you. In one of your slide, you have used x0 and x1 to calculate the next value. So I got confused. What does this x0 and x1 represent? It was the slide before evaluation. So can you tell about it a little bit?
Just a minute. X0 and X1. Just a minute.
Yeah. It was the slide before evaluation.
Before evaluation.
Yeah.
In initial population.
Yeah. In this, we are having
evaluation. This is a evaluation, right?
Yeah. Before that, we say
Before that, initial population.
Yeah.
Here.
We have used x equal to 2 square x1 plus 2 raised to power 1 x0. So what does this x0 and x1 represent?
No. This is not x0. It is just to convert any binary number into a equivalent integer number. Okay. So this 100 first, let us say the first string 100 is there. Okay. So how it can be converted, this 100 into an equivalent integer number? So it is equal to 0 into 2 raised to 0 plus 0 into 2 raised to 1.
This is conversion from binary to decimal.
Yeah. It is not x. It is a multiplication. X is not x. It is a multiplication sign. Okay. Is it clear? I think. Conversion of binary to an integer number.
Yeah.
Sir, I have one question. One question, sir.
Yeah.
So I want to use multi-object.
Multi-object here. Yeah, multi-object here. Your voice is not getting clarity.
Yeah. There is a little disturbance in your voice. Can you please type it in the check box?
Check box, sir. Not it.
So meanwhile, sir, there is a question in chat box.
Yeah.
I will read it for you.
Yeah.
Can the algorithm have any integration with embedded systems?
It can be there, yeah, definitely there, but it needs a little more knowledge. Embedded system you can definitely integrate, right? So this is there. It is quite possible, but you need to do some integration process that is required. In like, see, some sensors are there. You can collect the data from the sensors, and then after it can be processed. So this can be done, but it needs little more
Yes,
knowledge
sir.
of that thing. Yeah, it is definitely it can be done because it is used in many image processing softwares and many such kind of advanced such kind of a thing. It is used. Genetic algorithm is used. So it is done. I think you can find out also many papers on such kind of a things. People are doing it.
Sir, is it possible to have your email ID and mobile number if we want to
Yeah.
communicate
Yeah,
with you?
ma'am.
I
Provide
think
email ID of sir.
Vinit will give you, right?
Okay, thank you.
Yes, sir.
Huh? Yeah, Vinit, please, Professor Vinit
Okay.
will provide. Huh?
Yes, sir.
Okay.
Yes, sir. Yes. So since we are already out of the time now,
Yeah.
and we had